Hello, on this video we're going to talk about the electrical timers. So the other name we can call the electrical timer is the time delayed relay. So as you can see here, timer is actually a just special type of relay. So on this subject, we have very good reference. You can look at here. The first one, if you Google those keywords, you will see a comparison between the two standards, which is NEMA and NEC. Those symbols comparison. Right. The other reference is a website called the All About Circuit. They have the online textbook. One book is called Digital, and if you go to chapter 5, you will see the topic on the timer. Right. So let's move on to the slide on here. So on this slide, I summarized all the timer symbols together with timing diagram. So at the beginning, probably you will see the timing diagram is very complicated and seems not necessary sometimes, but as we go on the topic, you will see that timing diagram is a very good tool to communicate, to represent the in the engineer field, right? So we will have to learn about the timing diagram as we go to a different aspect of the timers. So first, let's look at the symbols. So because timer is just a special type of relay, so briefly review, right? So if we want to represent the coil, right, on the relay, we just use this circle, right, to represent the wire wrap around, right, to form a coil. So the same symbol we can use to represent the timer coil, right? Again, timer is just a special type of relay. So on the relay, we also have two different type of contact, right? One is called the normally open, the other one is called normally closed. So with that symbol, we have two different you can call two different sets, right? So on one set, it's very common. Is this one, two vertical lines to represent the two opening on the contacts. So that's why it's normally open. So when you have a line cross that, they'll be touching to each other. So that's why it's normally closed. So that's probably most common one we will see to represent the contacts from the relay. So based on that, we can have the timer's contact. Right, timer's contact also has the different type, right? So actually, on the timer, we can divide that with two different type of timer. So one is called on delay, the other is called off delay. So with each type of delay, we can have two different type of contact. So that's why the first one you can see here, a little bit longer name, called normally open, time close. So continue to use the symbol on the first set on here. We keep using the normally open. That's the symbol for regular relay, normally open contact. Then we have the letter right beside the contact, TC, represent time close. Right. So that's the first type of contact. And then the other side is very easy, right? Very easy to understand with the normally close, and you have the letter to represent timed open. So let's look at the timing diagram. All right. So based on here, you can see the right line to represent the power on the coil. Right. So on top, it's on. At the bottom, it's off. Right, so on the background, you can see I have the different lines to represent the time progress. Right, so each column represent. I want to use that to represent 1 second. All right, so for the first second, the coil is de-energized. Then after the first second, the coil being energized for 1, 2, 3. 3 seconds, then turn back off, right? So with the regular relay, I hope you understand the basic relay operation, right? With the normally open, so coil is de-energized, the contact is open. When coil energized, the contact become closed. As long as the coil energized, the contact is open for the whole 3 seconds on there. And then the normally closed contact will do the opposite, right? So normally closed, that means when the coil is being de-energized, the contact is closed. The moment when the coil being energized, the contact become open, and that will become open for the whole time while the coil being energized, right? Once coil become de-energized, the contact will go back to their normal state. As you can see here, follow this, right? They just doing exactly the same thing without any time delay. And the one we just introduced with the normally open, time close, you can consider that as a relay, but a little bit sticky, right? So with a time delay. So over here we just set up like for example, you can see on the diagram, you'll see it's 2-second delay. So that means at this column over here, right, the coil is already energized, but this contact will hold on, will wait, will delay for 2 seconds. That depends on your setup. So after 2 seconds, it will become closed. So that's why it's normally open, timed close, right? After 2 seconds, will become closed, right? The opposite is the normally closed, right? So over here is normal state, it's closed, and that start the 2-second delay, then eventually change to open. So that's what happened with the on delay, right? So the other set of the symbols, right, a little bit different. It's on here, on this part. So on this set, you can see they just use a bar, right, or moving arm to represent when there's a gap, that's normally open. When the bar is sitting on top here, you can consider that because gravity it pulled down here, so it made those two circles contact together. So that's normally closed. That's for the relay. Then on the timer, right? On the timer, we'll just add more component to represent the operation. So you can see this. You can consider that as the two contacts or 2 screws to wire a circuit, right? Then the moving arm is underneath the other side of the contact, right? And of course, because of the gravity, there will be a gap, so that's why it's normally open. Then we add a vertical line, and with the arrow point to upwards. So this arrow will represent after the time the movement will move upwards. So you can imagine with the movement upwards, this gap will become closed. So that's why this is the normally open, time closed. So even though the symbol itself is a little bit hard for you to memorize the function, right? This one is easier, right? Normally open, time closed. But this one, little bit story behind it, right? So you have to understand that. And unfortunately, in my experience, I feel that this one is more widely being used in the industry, in the engineer diagram. On this side, the very easy to memorize side is not very common. But I have both on here. The advantage on this is that we can easily to recognize the name, right? And the other advantage is later on when we move on to PLC, it's very easy to transition into PLC instructions with this symbol. But the disadvantage on this side is that it's really hard to understand this is a on delay. But on this side, because you can see the arrow point to upward, so that means it's on delay. Alright, so that's why you can understand this symbol easier if you understand what I just told you, the story. Right? So again, with the two circles, you can have the moving arm on the other side, so that again, because the gravity, they make those two contacts touch each other, right? So that's normally closed. Then the vertical part represent the timed movement. So the time movement after a certain period of time will move upward, right? Represent on delay. Then when you move this arm this direction, that will make over here a gap. So they are not touching anymore. So that's why this is what we call the normally closed timed open. Okay, so I think so far what I introduced with on delay is enough to begin with. All right, with the off delay, I will talk about a little bit more as we go. All right, so again, the timing diagram, we can continue to use this as we go into the examples. All right, so let's move on to the next slide. So first, let's look at the on delay example with the circuit. Right. So the first one we talk about is normally open, time close. Right. So again, symbols I list both of them over here. So we can have a trigger to energize the coil of the timer. So on this particular one, we set up at 5 seconds. Then from this timer, we have a set of contact, normally open, time close. TD1, TD-1 represent the contact that will control a pilot light. Right. So I just list both symbol over here. So the operation can be represented by the timing diagram. That's what I mean by here. So if you read the sequence of operation, sometimes it's really hard to describe that, to let everybody understand that. But if you have a timing diagram, it will become easier. So that's for the first one, let's go through that. So when the trigger is open, like right now open, right, that represent here, right, the coil is de-energized and TD-1 is open, PL is off, right? So that is open, right? The bottom one is open, contact is open, then the light is off. So that represent up to here, right? So the second event, when the trigger close, TD energized, that's the coil, right? So that start from here. Energized, timing period start, and it's still open because it will wait for 5 seconds. So that's basically up to here. Wait for 5 seconds, then nothing changed on this contact. It was open, it's still open. Alright. So and then on the sequence event 3, after the 5 second delay, the contact become closed and the PL will switch on. So the PL will turn on from this point up to here. As long as the coil energized, the light is on. Then after that, when the trigger is open, the moment when the coil de-energized, the contact open instantly. So remember that, because this is on delay, right? So with the off condition, there's no delay at all. It's instant option open, then PL switch off, right? So that's what you will see with this circuit. Then let's look at the other example for that. All right. So for example, if we want use a water level switch, normally open type, to control a pump. All right. So then because the let's see over here, I'll just draw a like a tank on here, right? So there could be like a float switch, right? So that will be the normally open one. So when the water going up, there's a ripple effect, right? So sometimes if you use the switch directly control the pump, when there's a very close position up there, your pump will have on and off like a shuttering, so you don't want to have that happen. So that's why you want to have a 5-second delay, right? So you need wait for the switch open for 5 seconds, then you start a pump, right? Again, so if you use a timing diagram, right, so flow switch is open, the pump is off, and then when the flow switch become closed, the pump will not start, but instead wait for the time period 5 seconds finish. So for example, during these 5 seconds, like I just mentioned, if there's a ripple effect, that will turn on, and then that will not turn on the pump. So that's why we want to protect the pump. So if the water level is really high, that will hold the switch all the way closed for 5 seconds. After 5 seconds, the pump start to turn on, right? So that's typical normally open, time close, right? So you can, if you want, we can start to draw the symbols to represent the flow switch. It's like that, and then we can use that to control the coil, right? So we can use that to represent TD, and if we label that flow switch, and then I'll just use the normally open, timed close to energize the pump. So that'll be a very simple design for this circuit, similar to the pilot light we learned before, right? So let's look at the next one. So the second contact with the timer on delay timer is normally close, timed open, right? So again, so I have the both representation on here, right? So normally close, time open, very easy to understand, and that symbol is also the same type of the contact. And the timing diagram, as you can see here, with normally close that represent when the coil is de-energized. When the coil is de-energized, the contact you can see here is at up level, so that means it's closed. So here comes the normally closed. And timed open, so that means at this moment when the coil start to energize, it will wait for 5 seconds. Here comes timed open, right? So this is normally closed and timed open, right? So the sequence of operation you can read through there. So if you really understand the timing diagram, the description is it's not really necessary anymore, right? So this is on delay. So far we have 2 of them, and one of the example I can talk about that is that if you think about the light in the inside the car, right? So some people call that the dome light. Dome light inside the car is controlled by a normally open type of limit switch, and that limit switch is controlled by the door. So when the door is open, the limit switch is open, so the light will turn on immediately. Then 3 seconds after the door is closed. After the door closed, we don't want shut off the light immediately, but we want to hold for 3 seconds. All right. So as you can see on the timing diagram, this is the door switch. When door switch is closed, that's, for example, you walk to your door, right? You walk to your car, the door is closed, and there's no light turn on inside the car. That's what you see here, right? The light is off. Then the moment when you open that, so the moment when you open the door, right? So the light turn on. You can see on here, it's no delay on here, right? So then as long as you have the door open, the light is on all the time, right? No delay to start and keep going on all the way. And then once you go into the car, you close the door, so the the limit switch, the trigger become closed, then the coil of the timer could be energized here at this moment. Then that start the 3-second delay. Right? So after you close the door for 3 seconds, after that the light shut off automatically. Right? So this is an example for the application with the normally closed, timed open. So the circuit design, I don't have to draw that anymore. Right? So if you go to the previous slide, and then pretty much that's the same circuit design on here. Right? But you need to use a different type of contact. Alright, so let's move on to off delay. So off delay is a little bit different, right? So I will explain a little bit on this one. So far we talk about the on delay because the timing start when the coil energized. But now you will start to see there's something timing start when the coil de-energized. So most notably, you can see here the time on here indicate when the coil turn off. Right? Remember that we have the on delay that always happen when the coil turn on. But this one off because it's off delay, right? So you can see here that's the symbol to represent the normally open, timed open. So at the beginning you may think, okay, this name is a little bit strange, right? Because it's normally open, why you have time after time you have open that again? That because in the between you have a instant closed state. Alright, so I'll explain that. So normally open is very easy to understand. When coil is de-energized, the contact is open, and then the instant close comes here. So when the coil start energized, the contact close right away. So that's the intermediate state. So when the coil energized, the contact will become closed forever. So as long as the coil energized, and then the timing start with the coil de-energized. So that's why it's called off delay. Off delay here. So when the coil is off, we start a 5-second delay, and then eventually we'll go back to the normal state, which is open. So that's why this is normally open, timed open. So the symbol itself, again, this one very easy to understand. Normally open, timed open. This symbol, you can consider that the two contacts, and then the moving arm has a gap. So that's the normally open. When you have the timed operation, you're going to downwards. When you're moving downwards, this gap gonna become open, right? So that's why the name, right? Normally open, timed open. All right. So let's see what kind of situation we want to have this normally open, timed open function, right? So here's a example I can show you on here, right? So for example, if we have a cooling fan, right? So that's a fan, and this fan will turn on whenever a selector switch SS is closed. So you basically use a selector switch and to turn on the fan, right? So when the switch flipped closed, the fan to turn on, right? Then continue to run for actual 4 seconds after the switch is turned open. So because it's a cooling fan, right? So probably you want the fan keep running for actual 4 seconds to cool off, right? For example, if it's a cooling fan for the oven, right? You want to have 4 actual seconds to run the fan, right? So that is a situation we can use this type of the normally open, time open switch. So for that, you can see when switch is open, the fan is de-energized, is off. The moment when switch turn on, there's off delay, right? But no the no delay on the on condition. So when it's on, the switch is on and fan is on, and that will keep going as long as the switch is closed. And then from this moment, when we have the switch become open, start a 4-second delay, and then eventually will turn off. Right, so that's again because it's off delay. It's waiting for the trigger become off. Right, so I can draw the diagram. That'll be very similar to the previous one. So over here again, if you have a selector switch, you can draw it in this way, and that will energize a time delayed coil TD. And for this one, you will have to use normally open timed open to energize the fan here. So that's the design for this circuit. Alright, and let's look at the last contact, which is the second type of contact from the off delay, which is normally closed, time closed. Again, let's directly go to the timing diagram. Alright, so with the coil on, there's no delay. It was closed, normally closed, it become open right away, no delay at all. So then after the coil being turned off at this moment, here, start 5 seconds. It was open before, right? It's still being open after the 5 seconds expire, go back to close. Alright, so this is the timing diagram and operation for the NCTC. So then let's look at the example. This example is sometimes it's really hard to find. So then let's look at it over here. Read on this one. So NCTC, from what I can think about in the everyday life, is that I can think about a sidewalk sprinkler, right? So the output will be a solenoid valve. The valve control the sprinkler, right? So when the valve turn on, right? When the solenoid turn on, the water come out, right? So, but it also has a photo sensor, which is normally open type of photo sensor. So when the sensor detects the pedestrians, so you don't want spray water on people, so that's why the sprinkler is turned off when immediately, right, when the photo sensor is being activated, right? As long as people is there, there's no water come out, right? So then when pedestrian walk away, and the photo sensor will be inactivated, but we don't want turn back on right away. We want to hold for 2 seconds. Then we will turn back on the water, right? So as you can see, this time the timing diagram can tell a better story about the situation, right? So you can see here at the beginning, the photo sensor is off. That means no people around. Then the solenoid is energized, the sprinkler is running, right? And then when the moment photo sensor being activated, there are people nearby, then the solenoid being de-energized right away, right? So that's why we use off delay. So whenever the sensor is on, the solenoid will be de-energized, right, for the whole period of time. So at this moment, the sensor will become deactive, but you don't see the solenoid turn on right away. It will hold off for 2 seconds, then turn back on. Alright, so that's the example we can use for the normally closed, timed close. Alright, this video is a little bit long. I think I can just stop here.